So if we look at our falling on stairs hazard profile in the HHSRS operating guidance, we'll see that it considers both stairs and steps inside and outside the property. We don't have really any stairs and steps outside the property because the system requires you to have what's typically more than 2 steps, so 3 or more steps. The vulnerable group is over 60s again, and our average property for a house that's pre-1920 is 218. Average likelihood of 280. So not quite as likely if it falls on the level as falls on the level. Just out of interest. The spread of harm outcomes, however, are more severe as you'd expect for falls and stairs. So 2.2% of the time, talking death or permanent paralysis, very serious injury. Class 1s, 7.7% of the time. Class 2s, 22.1% of the time is Class 3s, and 68% of the time is Class 4s. So if we then look down to our relevant matters affecting the likelihood and the harm outcome, there are all sorts of details around the dimensions of the stairs. And so if you've got staircases that are, so you've got a kind of model staircase, which is set out in the building regulations, approved document K. And that's where a sort of staircase you expect to find in a new build house. However, as you deviate from this, as the staircase becomes more shallow or more steep, the likelihood of falls increases. So tread lengths and riser heights are very similar or the same as what you would find in the building regs approved document, should I say. And so we're saying if you've got a tread length, which is the tread is where you put your foot, so the riser is the vertical part next to the tread on the staircase. So if you've got tread lengths that are outside of 280 to 360 millimeters, then you're going to make it more likely that someone will fall. If you've got riser heights that are outside of the range of 100 to 180 millimeters, a much smaller range, then you're going to make it much more likely someone will fall. Other things that can affect the property, so the chance of falls on stairs and steps, are variation in treads or risers. So that might produce an uneven pitch. You get this in much older staircases. But also if you're looking at winders, the stairs go around in corners, that can also impact on that. Nosing length, so this is the bit that projects, and usually as you go down the staircase, it's the bits that you are most likely to be in contact with as you move down the staircase. So if you think about a commercial building, usually you have either a plastic or a metal strip that's attached to the nose of the staircase there, which provides an extra bit of friction and makes it clearer where the edge of the nose is by using some kind of contrasting colour to pick it out. Now, we don't get these in residential properties, and the nosing lengths are quite variable, but they can catch your toes as you move down through the property. And they also restrict the available space on the tread for you to put your foot down. Poor friction quality, so for instance varnished wooden stairs as opposed to having just carpeted stairs. Openings, so this is where the risers from the stairs have been removed, particularly stairs through to openings in the guarding through which you can slip. Alternating treads, these are quite rare, but occasionally, because if you think about when you go up and down a flight of stairs, you're putting your feet alternatively on the treads, then they have invented some space-saver staircases or stylized staircases, which only provide enough wood to support your feet on the side in which you're more likely to tread, and these make falls more likely. an opportunity to, for instance, to go out of rhythm as you're going up or down these sort of stairs. Lack of handrails or handrails at a poor height, and lack of guarding, which make it more difficult for you to use the handrails to steady yourself for balance and to correct a fall once it's started. The easily climbed guarding, making it easy to get over the guarding and fall. Stair width, narrower staircases are more likely to have falls on. The length of the flight, again, so if you've got longer flights, more likely that you might tire if you're in that at-risk group, for instance, and have a trip step and start to fall. Inadequate lighting, so it's harder to see the staircase. Poor lighting controls, so they might just be in the wrong location for you to use for the staircase. Glare from lighting, making it more difficult to make out the staircase. Doors opening onto stairs, so you can either be pushed as someone opens the door and it pushes you down the stairs, or the door can open into you and strike you as you're moving down or up the stairs. You say that falls are much more likely as you're moving down the stairs. Inadequate lighting, disrepair to the staircase, and once again thermal efficiency. For the same reasons as with the previous hazard for falls on the level, thermal efficiency is an important factor when considering the likelihood of falls on stairs and steps. So looking at the words examples, we've got this one here which isn't terribly relevant because although it's got some winders on the staircase, it's quite a straight run on the staircase, and it's more about falls on steps outside. This one is completely different because just this odd spiral staircase arrangement. This one is a straight run of steps with a half landing and then straight down. It doesn't have handrails, but it's not really showing the situation with the winders we've got. Now for this one, which is actually it's a 1980s property, it's for a more modern dwelling, it's actually looking pretty similar to our property. So we've got a couple of sets of winders as the staircase goes down. This won't be as steep as our staircase. However, it doesn't have a handrail, and ours does have a handrail at least on one side for part of the run of the stairs. And ours also has a second flight of stairs in the same property. So if we look at what this has scored 1 in 180. Because we're in a different period of property, ours has got an average likelihood of 1 in 218 as a starting point. So, excuse me, if we were to put that on here, then actually if we look at this example, then 1 in 218 would fit in exactly the same representative scale point bracket of 130 to 240 as they've used in this worked example. So our property must be worse than this example. Now we've got 2 staircases and we've got steeper stairs in our property, and we have an excess cold hazard as well. So we're going to be jumping not just one representative scale point up. I would argue that we could probably jump 2 or possibly even 3 representative scale points up with choosing our likelihood. This property doesn't have handrails, which ours does, so that's something in its favour. So I might say that would rather than jumping through, you might go 2. So we've got 1 in 100 and then 1 in 56. So we're going to jump to 1 in 56 for our likelihood.